The radical symbol returns only the positive root. On the internet, I found this slideshow next to it, next to our problem, and it says square roots and the radical symbol returns only the positive root. This is called the principal square root of the number. To get the negative root, simply take the opposite of the principal root. So for instance, they gave an example, 25. The square root of 25 equals 5, and negative 1 times the square root of 25 equals negative 5. That's a concept that we're trying to understand. So we figured we would take this minute just to show it to you. So the radical symbol tells you that the number under it is positive. If we had the square root of 100, we would write it just like this. And the square root of 100, positive 100, because that's what the radical symbol tells us, that it's a positive number, the square root of 100 is 10. The only way for us to get a negative answer in this situation is just like what the example showed us. What the example showed us was that if I had the square root of 100, I would have to multiply that by a negative 1 in order for me to get that negative 10. Because what we're saying here is we are saying that negative 1 times the square root of 100, which is 10, equals negative 10. And that's the only way we're going to have a negative answer. In our next example, we can see that we use the word evaluate. What we're doing here is we're evaluating. We evaluated the square root of 100, and we know that it's 10. Now we're going to evaluate the square root of negative 100. As we said, that anything underneath the radical symbol is positive. That's what the radical symbol is telling us, that all the numbers underneath of it are positive. So since I see a negative 100, and that can't be, I'm simply going to write the words no real solution. And no real solution is going to be my answer for now. No real solution, because I cannot take the negative square root of a number. So let's look at our three examples. Our three examples are the square root of 81, negative 1 times the square root of 81, and the square root of negative 81. Starting with the first one, we can see this the square root of 81 equals 9. There's nothing to that. That's a perfect square. It's a positive radicand underneath the radical symbol, and that equals 9. Nothing to it. The next one is how we get a negative answer when we're taking the square root of something. We have a negative 1 represented by this negative symbol here times the square root of 81. That's going to give us a negative 9, and here's how it works. Negative 1 times the square root of 81, which is actually 9, equals negative 9. Finally, we have our last one. Our last one is something that gives us an answer, which is no real solution. The reason there's no real solution is because it's a negative underneath the radical symbol. The radical symbol actually represents positive. Any number underneath this radical symbol is going to be positive. And since it's a negative symbol, a negative 81 in this case, underneath the radical symbol, we're not going to do anything further except for write the answer. No real solution. So let's solve x squared equals 100. When I solve x squared equals 100, what I'm going to do is I'm going to use a radical symbol to help me solve for x. So when I do that, I'm going to draw my radical symbol over both sides of the equation. So here's my radical symbol over the x squared and my radical symbol over the 100. The square root of x squared is x, and the square root of 100 is plus or minus 10. We have to make sure we include both this plus and minus because we're not sure what we had in the original value for x. Was it a positive x? Was it a negative x? So we have to include both the positive and the negative here just in case to make it a complete answer. Let's take a second to look at the difference between solving and evaluating. In the original problem when we were solving, we started off with x squared equals 100. We had to use the radical symbol just to help us solve for x, and the answer was plus or minus 10. But when we evaluate the square root of 100, for example, the answer is simply the square root of 100 equals 10. There is no way to take the square root of a negative number. Therefore, if you have the square root of a negative number, the answer is going to be no real solution. I like to think that the difference between these two problems is the starting point. When they're asking you to solve, you have x squared equals 100, and this is where you start. When you're evaluating, you're given the square root symbol, and you're asked to find the value of that square root. So in one, we're solving for x, and in the other, we're evaluating the given expression. So when we're solving, as you can see, x equals plus or minus 10. But when we're evaluating, as you can see, you could either have the square root of 100 equals 10, or the square root of a negative 100 is impossible to do at this time, so we're going to write no real solution. And this is the difference between solving and evaluating. Solving examples that don't work out perfectly. On the left-hand side, we can see what we just did on the previous page. We solved for x, and it happened to be a perfect square. So x squared equaled 100. In order to solve for x, I used a radical symbol on both sides, and the square root of x squared is x, and the square root of 100 is a plus or minus 10. But sometimes things don't work out so perfectly. So I'm going to show you an example on the right-hand side of how things don't work out perfectly sometimes. And what that means is it doesn't work out to be a perfect square root in the end. So we're going to have a decimal as our answer. So the steps of this problem are like any other problem we've ever done. So I'm going to look at this. I'm going to say, how can I get that x squared by itself and get my numbers on the other side? So the first thing I'll do is I'll draw my wall. I'll subtract 4 from both sides of this equation, and I will end up with x squared equals 12. At this point, just like I showed you on the previous example, when I'm trying to solve for x and I have x squared, I can use a radical symbol to help me solve for x. And the square root of x squared, or in this case, h, is h. And the square root of 12 is not a perfect square. The square root of 12 is actually 3.46. And don't forget, guys, it's not just 3.46, but it's plus or minus 3.46. We can't forget that plus or minus because our problem will be wrong otherwise. So sometimes these do not work out to be perfect squares, and there's just one example. One last example before we're done with our comparison between evaluating and solving. So my last example is going to start off like any other algebra problem we do when we're trying to isolate the variable on one side. When I do that, I'm going to draw my wall, and since I have a positive 8 here, I'm going to subtract 8 from both sides of my equation. Now that I have done that, I can go ahead and combine like terms and rewrite. So on the left-hand side of the equation, I now have a negative 2x squared equals, and on the right-hand side of my equation, I now have a negative 41. Okay, so I'm not done. I still want to isolate that x even further. So what I'm going to do is I'm going to divide a negative 2 across both sides of the equation as well. I'm now left with x squared is equal to 20.5. And I know that I still want to isolate this further. I still want to solve for x. So since I still want to solve for x, I'm going to use a radical symbol on both sides of my equation to isolate this x even further. So here's my last step. The square root of x squared is x. And the square root of 20.5 is plus or minus 4.53. And this is just one last example of how sometimes when solving, your answer will not work out to be a perfect square.